Good afternoon, everyone. This is our physics alternative assessment on applied physics for a better world, done by Alicia, Sutong, Willard, and Sinkai. Our project is called When It Rains. To start, the issue that we're trying to solve is slipping in wet weather. Slipping on a surface due to wet weather conditions could lead to injury for civilians and may be especially severe for disabled or elderly civilians, according to a study conducted in 2019. In fact, rain and wet conditions increase the risk of falls by 17%. Hence, the goal of our project is to identify which materials are best used for the flooring of our urban environment by finding the material with the highest coefficient of static friction. In order to do so, we conducted an experiment using the tiles of three commonly seen floor materials: cement, concrete, and wood. Using a syringe, we placed a 3.4 cm by 3.4 cm barrier around 1.2 cm cube of water to simulate 1 millimeter of rainfall without the water running off the surface. We placed a small piece of rubber on the tile to simulate the rubber sole of shoes. Throughout the experiment, we used the app phyphox and its inclination function to record the angle of tilt of the plank as the string lifts the tile via the pulley. Here is the condensed materials and applications list and some screenshots of the phyphox application. After setting up the experiment, the string is pulled slowly such that the tile is rotated continuously. When the rubber starts to slip, the angle of which it occurs is recorded down. For each material, the experiment is repeated twice, with and without water, so there is a control experiment to make comparison to. Each data recording is done 6 times. Do note that the video is sped up due to time constraints.
Now, I will be covering the analysis of results. This is the free body diagram of the rubber slab on the inclined plane. We define the x-axis as parallel to the plane of the tile, where the y-axis is perpendicularly upward from the plane. There is a normal contact force acting on the rubber slab perpendicularly to the surface as well as weight that acts directly downwards, which can be resolved into the x and y components. Static friction acts along the plane, opposite to the tendency of motion. When the object is in translational equilibrium, the sum of forces in the x and y direction must both equal 0 according to Newton's first law. Hence, as we increasingly tilt the plane at every instant before the rubber starts to move, N equals to Wy and F equals to Wx. As theta increases, Wx increases and Wy decreases. Consequently, as the magnitude of Wy equal to that of N, the value of N decreases as theta increases. Since the maximum value of static friction is given by F equals to mu N, where mu is the coefficient of static friction, as theta increases to the maximum angle of tilt, N decreases, thus maximum static friction decreases too. With Wx increasing and F decreasing, there would be a point where Wx just exceeds F, causing the tile to accelerate downwards or slip. This occurs just slightly after the maximum angle of tilt. Hence, by manipulating the equation, we find that the coefficient of static friction equals to the tangent of maximum angle of tilt, where a higher coefficient indicates a higher maximum value of friction, and thus the less slippery is the surface.
Here are the results for the angle of tilt when the piece of rubber starts to move, and the respective coefficient of static friction. For concrete when wet, there is a 5.8 degrees decrease in the maximum angle of tilt and 0.144 decrease in coefficient of static friction, as compared to when dry. Here we see similar trends for cement, where there is a 5.8 degrees decrease in angle of tilt and 0.145 decrease in coefficient of static friction under wet conditions compared to when dry. And the trend holds true with wood, where there is a 23.9 degrees decrease in angle of tilt and 0.689 decrease in coefficient of static friction when wet as compared to when dry. The coefficient of static friction between rubber, concrete, and cement and wood, and all decreased when there is a simulated 1 mm of rainfall height. This means that all materials became more slippery and wet as expected. As concrete and cement are generally similar materials, both share largely similar coefficients, with and without rainfall, with concrete being slightly less slippery. Wood had the highest coefficient when dry, which is probably because wood is much rougher than the other two materials. However, wood has the lowest coefficient when in wet conditions, likely because the vinyl coating prevents water from being absorbed, thus more water remains to lubricate its surface.
Moving on, I will be talking about the possible experimental errors which may have affected the results. Firstly, the water may have acted as an adhesive instead of a lubricant between the two surfaces, allowing the rubber to stick to the tile instead of slip. Secondly, given that the materials are all porous, some of the water may have been absorbed, lowering the actual volume of water present on the surface, resulting in less water on the surface than what we defined. Hence, the more porous materials will have less lubrication from the water. These two errors will increase the maximum angle of tilt, thus resulting in a larger value of tangent theta, resulting in a coefficient of static friction that is larger than the accurate value. As for the precision, the values we collected are relatively close to each other, and there's no anomaly within the recorded results, because there's little random error. However, as we are recording the angle of tilt after the rubber tile starts to move, there's inevitably some error caused by human reaction time. As for the accuracy, there should be little to no systematic error when using the phyphox inclinometer, as it is calibrated against a flat surface. Now, let's find out which are the best materials for flooring. Concrete has the highest coefficient of static friction when wet at 0.632 and should thus be used outdoors where it rains frequently. However, in dry conditions, we found that wood was the least slippery as wood had the highest coefficient of 1.17. Therefore, it is recommended that wood should be used for indoor flooring. We hope that this project gives you a better understanding of how static friction plays a part in ensuring our safety when walking on certain surfaces, especially in wet weather conditions. Thank you.